Okay, welcome student. Now we'll discuss on the part 5 on this chapter 12, which is on the area related to a circle. Okay, now before coming to the exercise on this chapter, let us first know some of the important definition that will come across in this chapter. Okay, first is a chord. What is a chord? A chord is a line segment that join the circumference of a circle from one end to the other end. Okay, if you draw a circle and draw a line from passing from one end of circumference to the other, that will be called as a chord of a circle. Now, out of so many chords that you can draw on a circle, the longest of all of these chords will be called as the diameter, and this diameter passes through the center of a circle. The diameter is the longest chord of a circle which passes through the center. Okay, now what will be, if r is the radius of a circle, what will be the diameter? Diameter will be twice of radius. Diameter is twice of radius. Its radius is 5 centimeter, then the length of diameter will be 5 plus 5, that is 10 centimeter. And if the diameter is given to be 10 centimeter, what will be radius? Radius will be diameter divided by 2. 10 divided by 2, this is 5. Okay, now you remember this thing, that if the radius is given, you can find out the diameter by taking diameter is equal twice of radius, and if diameter is given, you can find out the radius by diameter divided by 2. Okay, now coming to the next, the arc of a circle. What is the arc of a circle? The arc of a circle is a part of the circumference, and this arc of circle is denoted by L, or the length of this arc of circle is denoted by L, and we can find out the length of the arc by this formula. L is equal theta by 360 2 pi r. Okay, this is the formula for finding the length of an arc of a circle. What is theta? What is theta here? Theta is the angle subtended by this arc at the center. If you draw a radius from one end of the arc to and the other end joining from the center, this radius of circle will make an angle between them, and that is the angle theta, or it is the angle subtended by the arc at the center. Clear? Now, if theta is equal 360, then what will be the length of the arc? If theta is 360, then you have 360 by 360, that is, you can cancel each other. You'll have only 2 pi r. What is 2 pi r? 2 pi r is the length of the circumference, isn't it? Now, if theta is 360, that means you need to find the length of this arc from the whole of this arc, mean the whole of the circumference will be the same formula, 2 pi r, which is the length of the circumference of a circle. Okay, now coming to the next, which is on a sector of circle. What is a sector of circle? It is the area enclosed by an arc with the radii of a circle described by the angle theta. Now you look at the circle, only this part of the arc is called, this part of the circumference is called the arc of a circle, and the area bounded by this arc along with this radius of a circle, that will be a sector of a circle. Okay, here I've shown for you this portion will be called as the sector circle. And here, for finding the area of sector, it is given by this formula, theta by 360 pi r square. Why is given like this? Because this sector is a part of a circle, isn't it? Arc is a part of a circumference, but sector is a part of the area of the circle. Part of the area of a circle. The same thing here. If you put theta by 360, then you will have pi r square only, which is the area of circle only. And now the perimeter of sector. What is the perimeter? Perimeter is the sum of the length of the perimeter is the total length of the boundary of a sector. If we are calling perimeter, if we are to find the perimeter of sector, that means in a sector, what are the things which make the boundary of sector? Sector is bounded by, on one part is bounded by the arc of a circle, on the other two part by the radius. That means r plus L is the perimeter of a sector of a circle. Clear? Now you keep in mind all these things. You will be using all of this in solving the problem from this exercise. Now coming to the next, it is a segment of circle. If we draw a chord on a circle will be divided into two parts. Here I've drawn a chord AB on this circle. You will get this circle, the whole circle will be divided in two parts, and if one part is a smaller part, the other is a bigger part, the smaller part will be called as minor segment and the major part will be the major segment. Clear? This part will be the minor segment and the major part will be major segment. And if they ask us to about the minor sector and major sector, what are minor sector? Minor sector is the area bounded by this minor arc at the center, and the area bounded by major arc at the center will be the major sector. Now going to the textbook question from here with the problem number 1, find the area of sector of circle of radius 8 cm and the angular center is 30 degree. Now as we have discussed that if we know the radius and the angle subtended at the center, then the area of sector will be given by this formula, theta by 360 pi r square. Substituting the value of theta and r, theta is 30 by 360, pi we know is 22 by 7, and radius is given 8, therefore 8 centimeter square. Okay, 8 centimeter square mean 8 multiply 8, 64. Then 30 with 360, you will go with 12. If you cancel 0 from numerator and denominator, you have 3 by 36. Then 3 multiply how much? 36. 3 multiply 12. Here on the right side option to you, 8 square is 64. Cancelling this 3 and 36, you go with 12. Then this 12 you can cancel with 4. 4 3s are 12. 4 how much? 4 1 4 1s are 4. remaining 2 with 4, 24, 4 is 24. Now 18 multiply with 22 and then divide by 7 multiply 3, 21. Okay, you are getting 352 by 21, and here I've shown you division. On dividing this, you will get 16.76 cm square, and the area of the sector will be 16.76 cm square. The next, the chord of a circle is of radius 14 cm, subtend right angle center. What will be the area of the minor sector? Minor sector is the area made by the minor arc at the center. Okay, now look at this circle I've drawn for you. Now let's suppose that AB is a chord which make an angle 90 degree at the center O. Then the minor sector will be the area subtended by this arc AB at the center. That is, this will be the minor sector only. Okay, this will be the area of AOB. This portion will be the minor sector. Now theta is 90 degree, radius 14 cm. Then same thing, using by the formula for the area of a sector, theta by 60 pi r square. Substituting value, theta is 90 and radius is 14. Okay, cancelling 0, 0, 90 and 60, 0, 0 here, 9, 36. 9, 36, you will go with how much? You will go with 4. Therefore, cancelling 90 with 60, you will go with 4. Then 14 square is 196. Then cancelling this 196 with 4, 49 is 196. Okay, you have 49. Then 7 7s are 49. Then remaining 7 multiply 22, which is 154, is the area of the sector which make an angle of 90 degree at the center. Going to the next problem. Here the chord make a chord of radius 14 cm makes an angle 60 degree at center. Find the area of the major sector. Okay, here 60 degree is make an angle of 60 degree at center. Then we don't need this minor sector. If we are to find the area of the minor sector, then you will use theta equal 60 degree. But the question here asks us to find the area of the major sector. Major sector means the area bounded by the major arc at the center. Then how you will get the angle made by the major arc at the center? Total angle at the center is how much? Total angle is 360. Then this minor sector minus arc make an angle of 60 degree. Therefore the major arc will make an angle of 360 minus 60 degree, which is 300. That means the major sector will be having an angle at the center as 300 degree. Now using by the same formula, and radius is 14 centimeter, 300 by 360 multiply pi 22 by 7 multiply radius square 14 multiply 14. Then 14 is 196, the same as the previous case also. 30 by 36, cancelling 30 with 36, you go with 3 10s are 30, 3 12s are 36. Then 12 and 196, you go again with 4 3s are 12, 4 49s are 196. Then 7 7s are 49. Then you will have in the numerator 7 multiply 22 multiply with 10, which is 7 multiply 22 is 154, multiply with 10 1540, divide by 3. Hence the area of the major sector is how much? 1540 divided by 3 centimeter square. You can keep as it is. You can keep like this also, or you can again divide 1540 by 3 and express as a decimal representation. Okay, you can divide this by going decimal, or you can keep as this. This will be the area of the major sector of the circle. Okay, the only thing that you have to be clear with here, the problem here asks us to find the area of the major sector, not the area of this minor sector, not the area of this smaller sector. Smaller sector you can easily find out by putting theta equal 60 degree, but here we are not asked to find the area of this minor sector. The question asks us to find the area of the major sector. Now, how to get the area of the major sector? You need to find the angle subtended by the major arc at the center. Okay, now if this smaller arc subtend angle 60, then the major arc will subtend an angle 360 minus 60, which is 300 degree. Okay, now going to next problem number 3. Find the angle subtended at the center of a circle of radius 5 centimeter and an arc is of length 5 pi by 3 centimeter. Now they ask us to find the angle subtended by the arc at the center. It's given that the length of the arc is 5 pi by 3 and the length of radius is 5 centimeter. Okay, now we know that the length of an arc is given by which formula? Theta by 360 2 pi r. This is the formula for finding the length of an arc. Okay, now but the length of an arc is given as 5 pi by 3, which means that theta by 360 2 pi r should be equal to 5 pi by 3. Okay, now you need to find the angle theta, isn't it? Therefore you cross multiply all of these terms to the right side, keeping only theta on the left. On the numerator you have 5 pi multiplied with 360. On the denominator you have 2 pi r multiplied with 3. Okay, now cancelling pi with pi, then r, which is the radius of a circle, it is 5 centimeter. Therefore cancelling 5 with 5, you'll have 360 divided by 6, which give us 60 degree, isn't it? Hence the area subtended by this arc at the center is 60 degree. Now the next problem, number 4. An arc of length 20 pi subtend an angle 144 degree at center. Find the radius of circle. Here also the same thing. We will use by the formula. The length of an arc is given to be 20 pi, but the formula for the length of an arc is theta by 60 2 pi r. That means theta by 360 2 pi r should be equal to 20 pi. Cancelling pi on the left and right side and putting the value of theta is given to 144 degree. Cancelling this pi, and then you need to find the radius. Therefore you keep r on the left side. You cross multiply all the term to right side. 20, you will have only 20. Numerator you have 20 multiply with 360 divided by 144 multiply with 2, isn't it? Because pi you have already cancelled. Then on doing this simplification here, you will get radius to be 25 centimeter. Okay, you do the calculation by yourself. You cancel all this number which is possible to cancel. You see 2 and 20 you can cancel, then 144 and 360 you find out by which number you can cancel these two, and at the end of this you will get radius to be 25 centimeter. Clear? Next we go to the problem number 5. What is the perimeter of sector of circle? What is the perimeter of sector of an angle 45 degree of a circle with radius of 7 centimeter? Here is given the angle theta, which is 45 degree. The radius of circle is given 7 centimeter. What do we need? We need to find the length of an arc, because perimeter of a sector is bounded by radius and the length of an arc. That means you need to find out the length of an arc of this circle. Now length of an arc is given by this formula, theta by 62 pi r. Substitute the value of theta and value of r. Theta is 45 by 60, multiply 2, multiply pi is 20 by 7, and r is 7 centimeter. Cancelling 7 with 7 in numerator and denominator. 45 with 360, you will go with 8. 2 multiplied 22 is 44, divided by 8, will give us 5.5 centimeter is the length of the arc. Then length of the arc plus radius, that means L plus twice r. L is 5.5, twice r means twice multiply 7, 14. 14 plus 5.5 is 19.5 is the perimeter of the sector of the circle. Clear? Now for today's class we'll end here and we'll continue again on our next class.